to have a, right, let's move this out of the way. We need all of you to be on the same, some kind of level, same level in terms of knowledge base. So today I will introduce you to R. Yesterday we talked about what requirements, who's a data scientist, what do you need to be a data scientist, both in terms of temperament and in terms of skill sets, so aptitude and attitude. But today we're going to switch and talk about R today. So that's all we're going to talk about. So let me share my screen and we will get started. Now, if you are experienced in R, you're going to find today's session extremely boring. So you might consider leaving so that you don't waste your time, because I'm assuming that you have never heard about R. And so we're going to just start from the very, very basics, as if you know nothing about R. So again, if you're an expert in R and you're writing functions and all of that, you might want to leave, because you might not necessarily, this might not be the session for you. So just sharing that up front, so you don't say, oh, I just stayed and I wasted my time. So please, you are warned now, please, so you can leave if you feel that this might not be the session for you. All right, let's get started now. So first things first, sharing the words of Aeschylus, he who learns must suffer. So there's no expectation that somehow this small session or this session today and tomorrow, you will then become an expert in learning R. No, absolutely not. So there's an expectation that you will have to go and suffer. This is just a gentle introduction, or maybe a rough introduction, as you might, into R, but most of the learning will have to come from you. And so one of my favorite philosophers is Aeschylus, the father of tragedy. Aeschylus says, he who learns must suffer. So again, that you have to apply that to yourself. All right. So let's start from the abstract. There's a whole world of art called abstract art. When we say something is abstract, it means that somehow in our mind, there is nothing we can compare this new information or this new fact or data point we've seen to anything we know already have known, right? That is when we say something is abstract, like, wow, geez, I cannot relate this to anything I've already known. Now, programming in general sounds very abstract to people. Like when people see code, it's like they instantly have a headache, but it doesn't have to be that way. And so we'll try to make programming less abstract. And the one way to do that is to compare it to what we know already. And the one thing we can compare programming to is language. We all speak a language. So if you can speak a language, whether it's English or whatever your native language is, then that means you can write code. Because programming is just a language. The same way we're speaking in English, well, that's what coding is too, right? And so when the first thing you learn about language is, remember when we were small, taught us nouns and pronouns and verbs. They'll tell you that a noun is a name of a person, place, or thing. A verb is a doing word. Then you learn about punctuations, comma, full stop, and so on and so forth, right? You gradually learn those rules, and you still use those rules till today. And that is all there is to programming, regardless of the language, whether it's R, Python, Rust, C#, C++, all of them. It's just this exact same thing, right? It all starts with going to the library to get a book and figuring out all of those things. So we're going to relate learning R, or any language for that matter, to learning the language. And hopefully that should be less abstract. The Pareto principle applies here. The Pareto principle says, essentially, also known as the 80-20 principle, you don't have to put in 100% of effort to get results. You just with 20% of effort, you can get most of what you need to learn. So put in other words, you don't have to learn every single function or framework in R or any other language. Just 20% of what exists is enough for you to go out and do great things. So that's what we're trying to emphasize. So that alone should make it less overwhelming to you that, oh my gosh, I don't have to learn all these things that exist. We just focus on the 20% that are the most important, and that covers every single thing that we'll need to know. It's just like the English language. Obviously, nobody here knows all the words in the dictionary. Well, maybe some of you do, but that would be very weird. But you still are able to have a normal conversation and write excellent manuscripts, even with the little you know. So that's the same thing that applies with programming as well. So again, just to emphasize that, R or any other programming language is just like English language or whichever language you are used to speaking. So we're going to learn about punctuation marks. We're going to learn about verbs and nouns, and we're going to learn about just some rules of syntax. And those are going to be exactly as we would learn in English or any other language we speak. But let's start with the library, because everything starts with library, right? If you want to go and learn French now, you go to the library and you pick up a book and you learn. So, pop quiz, which library is this? Let's see those of us who watch movies a lot. Who knows what library this is? Nobody? Exactly. Yes. So this is the Hogwarts library, right? And that is I don't even know his name. The guy, right? The magician guy. And so in this case, he wants to cast a spell. What's his name again?
Harry Potter.
His name. Sorry?
Harry Potter.
Thank you very
Harry
much.
Potter.
Thank you very much. Yeah. So, like, Harry Potter has a task, right? So let's compare what Harry Potter does to what we do in programming, because it's the exact same thing. So he has a task. He wants to defeat he who should not be named by name, right? Or Lord Voldemort. And so he has to go and, first of all, find the book, right? So, because spells are organized into books. So he finds a book, first of all. And then within that book, he has to now scroll down and read through the book and find the exact spell that he needs to use to do that task. Well, that's the exact same thing we do in R or any other language we're using, right? Things are organized into books. But once we get the book, obviously not everything in that book is relevant for us. We have to now start flipping through that to find the exact spell or the exact package or the exact function that we need, right? And so that is exactly what happens too. So in this case, you have a book, like you would have the whole package. Like in R, you have how come these lines just keep coming up all the time? Like, is anyone can prevent these lines from happening? Is it that people do some things and then the lines show up or what?
Oops. No, they're quite bad today. Someone is taking notes.
Okay. Okay, let me stop sharing and start sharing again.
If you're taking notes, please just try find another method.
All right. Can you confirm you can see my screen?
Yes, I can see.
Yes, we can.
All right, super. So we'll find a book, like Harry Potter's book. Then we have to now read through that book to find the exact spell we want. So in R, the books correspond to what we call packages, right? So we go to the library, and we actually have something called library in R, right? So that corresponds to the book, right? In this case, for example, if I'm analyzing complex survey data, I would want to find this book that has everything about surveys, right? And then when I get that book, I'll then have to now find the exact spell that I need, which would be the exact, particular function that I need to do whatever it is that I want, right? So, and this is where ChatGPT comes. You're so lucky now, you live in an era where there's just so much information. Like if you wanted, okay, what package has this information? Well, there is so much information everywhere. So if, for example, I'm doing analysis in R and I'm saying, okay, I want to do an analysis of complex survey data, I have no clue what package I need, just ask ChatGPT, what package in R can I use to calculate percentages in a complex survey? ChatGPT will get it right 99% of the time. So in here, it says in R, you can use a survey package to analyze data from complex surveys. The survey package provides functions, right? So the book is the survey, and the functions are like the spells, right? So it has functions. So for example, SVY total, that is a function. SVY by, that is a function, right? And then it even gives you instructions. So it's so easy for you to learn all these things, right? You don't have, again, let's go back to what I was saying originally, that you don't have to learn everything. You don't have to know everything. You have ChatGPT. This is what you should be using ChatGPT for, to learn, right? And so it can really help you to guide you. At the end of this session, I'm going to give you a homework. And so even if you have not been programming in R, I expect you to use ChatGPT to figure out what you need to do and then to do it. So even if you don't know what packages to use, you should be able to, first of all, understand the problem. See, that's the most important thing you contribute. You should be able to break the problem down in your head and say, okay, I think that I need to do this, and then I need to do that. Then you can then ask ChatGPT, how can I do this? But if you don't know what to even ask, if you cannot even frame your question in an intelligent way, then obviously ChatGPT, nobody can help you at that point, not even ChatGPT. So that's a homework we're going to give. Most of you use Stata, at least in our past classes, most of you use Stata. So I thought I'll also make a distinction between R and Stata. So this is like Stata. You have a garage and then you have one car, right? This is like R. You have like a massive park where you have hundreds or thousands of cars. So in Stata, you can only pack one data set at a time in the software. So only one data set can be in the software at any given time. In R, you can pack a whole bunch of data sets at the same time, right? And so that is a fundamental difference. And that has a huge implication on how we analyze data or how we even frame our syntax. Because again, keep in mind this mental image of, okay, one car parked in the garage versus a million cars, and try to think of the implications it has on every single thing we do when we analyze data. The easiest one is this. Imagine you're having a conversation with your auntie. And auntie says, hey, Richard, please go and fetch my bag from a red car. So what's the immediate dilemma that Richard has now?
There are many red cars.
Red car.
Exactly. So there are many red cars, right? So think of the context where we have, contrasting R with Stata, where you have many, many cars or many, many data sets packed in the software at a given time. That creates a problem, right? And so that for us to be very specific, that means that we need to reference exactly what we need. So in this case, and Jemima has to say, oh, go to the car whose license plate is ABCDE. And then there's no confusion at that point because we have referenced the exact car we want. So the point I'm trying to make here is that when you're analyzing data with R, that you have to be, you can't just say, go to the red car. It's like, which red car, right? You have to be very specific with regards to what you're referencing. And so again, this is a very, very important principle, which we'll refer to back over and over. And so that leads us to the concept of names. If there is one thing that is very intuitive to us as humans, it is the concept of names. Like everything around us has a name. Like just look around you, there's nothing that does not have a name. Like we give names to everything. So the pillow, a nightstand, and bed. Like everything has to have a name. When you go, imagine you went to a conference. Names serve more than just sentimental reasons. Go to a conference where there are a whole bunch of professors and you say, hey, professor. See, that creates confusion, right? Everybody's going to turn and say, hey, are you referring to me? Right? So you have to be specific and say, hey, professor, XYZ, right? Now you have been very specific and only he will respond. The same thing applies to data sets. I mean, even God understands the importance of names. The text in the scriptures tells us that the Lord brought animals to Adam and he had to give them names. So even God appreciates the importance of names. We're also told that even the stars of the heavens have names and he calls each one by its name, right? So that provides a lesson for us. So even if God understands the importance of naming even things that are as numerous as stars, well, that is a lesson for us too. So we too have to call each data set by its name. Because remember that in R, you can have multiple data sets all packed together. So the only way we can differentiate one from the other is by calling them by their name. So let's talk about names. So when you assign a name to a variable or to a data structure, that automatically makes it become an object, right? So that is how objects are created. You assign a name and automatically it becomes an object. So an object is a container that holds data, and the name is used to reference or access that object. So it's like I say, hey, hey, Robert, I want to see you here. Well, I'm trying to access the object called Robert, right? And he's only an object because he has a name. If everybody were here and I don't know who their names are, and I just say professor, that's confusing. So that's why we assign names so that we can reference things easily. And so once you assign a name, then that stuff becomes an object. All right, I have a riddle for you here. Do I have a name because I'm an object, or am I an object because I have a name? What do you think?
I'm an object because I have a name.
I'm an object because I have a name.
Yes.
Okay. Any other dissenting opinions? Is it possible?
I think both
ways.
opinions are
Both
not.
ways.
Them are.
Yeah, both of them are correct.
Yes.
To some extent, right? Do I have a name because I'm an object? Well, sure, but is it possible to be an object and not have a name? What do you think?
That's true,
No. Yeah.
Okay, it's possible, obviously. I think this is, in real world society, we have a very similar construct to this, where people will say a particular child is an illegitimate child. I couldn't think of anything that is more offensive than that construct of a child being illegitimate. What makes you legitimate as a human being? Is it that you have a name to append to as a family name? Or what grants you legitimacy as a child? And maybe we have drifted into the philosophical space now, but what are your thoughts? Am I illegitimate because I don't have a name, a family name to append to me? What are your thoughts? What grants you legitimacy as a human being? Is it complicated? I promise it's not a trick question.
Okay, a child born out of a red doctor.
Peter, I really love your answer. Peter said life. That you have life, yes, that by itself grants you you are a legitimate individual because you have life, not because your father, you know your father's name or you don't know it or whatever, right? The mere presence of life makes you a legitimate individual. And so that's why I take issue with that concept of, oh, that child's an illegitimate child. No, everybody's legitimate by virtue of the fact that they have life. Anyway, I digress from data. So, well, the concept of names, you can be an object and not yet have a name. That's possible. But that we give you a name means that you are an object. So anyway, that's just a riddle. So what are some naming conventions? You want to keep your name short, keep it memorable, keep it unique. By unique, we mean that don't give two columns the same name, and keep it standardized. Have your own convention for naming things, so that you have your own style. It's your own flavor of doing things. All right, let's talk a little bit about objects and why they're important. Why do we create objects? Because remember we said that it's possible that it could be an object without a name. But then why do we create objects and assign them names? Well, we'll talk about this lady, Sarah. This is Sarah's kitchen, quite cluttered, right? Everywhere is messy. If you send somebody to come and fetch something from here, they will spend quite a minute here because they'll have to look for it because there is no organization. Well, if Sarah has a change of heart, see, this is what she could transform her kitchen to. Now, this is way more organized. We have the lentils in one object and the chickpeas in another, and everywhere is now clean and organized. It makes it easy for us to reach out and retrieve things. And we have put labels on everything very clearly, right? So it's very easy for us to identify things. So that is essentially why we do, that's why we label things, and that's why we create objects, so that it's easy for us to reach out and fetch things. And we're going to talk more about this later today and also in our session tomorrow. Now, R versus R Studio. Those of you who, again, our poll yesterday showed that most people have not used R. So let's look at the difference between R and R Studio. This is, you can find it. See, this is R Studio, right? So you see, it's very nice. Everything is beautiful. It's pretty. You can write, you see as you write code, the codes are numbered clearly. See, there's color that allows you to see there's some things are blue, some things are green, some things are black. And so this is R Studio, right? As you type things, if I say, row names, and I start typing something, it pulls up, because this is vacant now. I don't have anything, but to pull up the variable names as you type them to suggest that, oh, this is what you want to type. So this is R Studio. So you see, it's clean and nice and beautiful. Now let's see R, base R. See, this is base R. Base R is just like, it's just one boring interface. So you will get the exact same answer whether you use R or R Studio. But this one is more like eating your pizza with your hands, and R Studio is like this fancy way of eating pizza with a knife and a fork. But you're going to get the exact same answer whether you use R or R Studio. So at the end of this session, I'm going to give you homework, and it doesn't matter whether you do it in R or R Studio. I'll provide you the links to R and R Studio so you can download it for the homework. So let's go back to programming. So we said that learning R is like learning the language. And just like any other language, we have to learn some basic building blocks. We have to learn nouns, verbs, punctuations, and logic. Because this is exactly what you have to learn in any language. If you're learning English language, which the very first thing you're taught in school is a noun is the name of a person, place, or thing. A verb is a doing word, an action verb, whatever it is, however they describe it. So the same thing, we have to learn that in R. We have to know what nouns are. We have to learn what verbs are and punctuations and so on. And that's where we're going to now take everything together and write elegant code that does magic. So what is a noun? A noun, as we're taught, is the name of a place, thing, person, or animal, right? So the same thing with R. We have nouns. A noun is an object. So remember we talked about objects earlier. Now I'm keeping it very simple. So these are broad generalizations. Now, if we start digging into the nuances, there are always a few exceptions. But for this particular, class, I will not dwell on this exception. So we're just going to talk about the generalities. And of course, there will be exceptions. To every rule, there's an exception, but you don't need to know the exceptions now if you're just learning R. So we're going to focus on just broad generalities. So a noun is an object. We talked about how we create objects. So think of an object as a noun. And so objects could be scalars, could be vectors, matrices, data frames, or lists. When you start learning about data analysis, there's a word that you use called data set. What is a data set? And why did I not put a data set here? Who can tell us what a data set is? Because you use that word quite often, right? Every single time. So what is a data set? Sorry?
How far now?
Please, Lawrence, can you
didn't.
mute yourself, please?
You have corrected some things now. I don't know whether
I
it gets.
think data
At
Mr.
least we
Lawrence, can
don't
you kindly mute yourself?
plagiarize. Worse than people here go to where they copy from.
Mr. Lawrence Atta Kulu, can you kindly mute yourself?
I had an idea. You did the other side.
Longile, can you
I
mute
doubt
please?
you know the domain.
Thank you very much. All right. So what is a data set? And how is it different from a data frame? So that we get the lingo right.
I think data set is the particular data you have at your disposal that you want to work with.
Okay.
And data frame is how the data set has been saved, either as CSV or Excel.
Okay. All right. That's well. So which is more broad? Which is a broader term, data frame or data set?
I think data set is more broad than data frame.
You're sounding very distant. Can you? I think you might be using headphones.
Yeah, sorry. I think data set is more broad than data frame
Okay.
because data frame is kind of like a table,
Very good.
while data set, it could be like different type of data. It could be like, for example, structured data, unstructured data, or any.
If we were to give one name, you are excellent, very excellent. If we were to give one name to all of these things, what would we call them? If we were to just give one name to all of these things, whether it's list, data frame, matrix, vector, scalar, and unstructured data, what would be one common name for all of them?
Data sets.
Exactly, data set. The data set is not a scientific term. It's just a colloquial expression that means, oh, my data I'm working with, whether in whatever form, shape, appearance that it is, right? So a data set is just a very loose term that means that could mean anything under the heavens. Somebody tells you, oh, I have a data set. Like, okay, can you please specify what kind of data set do you have? Is it a data frame? Is it unstructured data? Is it a vector? Is it a list, right? So a data set. So what the point I'm trying to say is that you should please, in technical communication, try not to talk about data sets because it's a very loose colloquial term that doesn't mean anything much. So these are so let's talk about what each of these things mean. So remember yesterday when we were talking about data science, of course, we've shifted gears today to data analysis, but yesterday when we were in the course of data science, our session, I said, you have to have a deep understanding of data structures before you can be a good data scientist, because you'll have to engineer products. You're going to create features and you're going to bring things to life, right? And so, yeah, you need to have a thorough understanding of data structures. And this is the foundation upon we're going to build on. So let's look at each of those things and what they mean, because you're going to be using a lot of these things in your work as whether it's a data scientist or data analyst. So let's look at all of these ones here. Let's start with a scalar. A scalar is just a single number, 5, 6, 7. That's one number, right? That's a scalar. A vector is one single column. Someone say vector, it's one column. Everything is the same type in the vector. So you can have a vector of strings or a vector of numbers, right? But it's just one single column. You have a matrix, and then you have a data frame. What's the difference between a matrix and a data frame? They look similar, for sure.
A data frame contains words and figures.
Okay.
Right.
Okay, now can you now generalize what you've said? You're right, but we want a generalized form of what you just said now. So a matrix can only do what? Can only contain what?
So,
Numbers.
a matrix can contain numbers.
You are being too specific. It can only contain one type of data class.
Yeah.
Yeah.
right? A data frame can contain one column could be anything, and then the next column could be any whole bunch of other things. So now you already see, this is why you have to know these things, right? Because now you're trying to create a product that it doesn't matter whatever feature you're trying to create. You have to figure that this product I'm trying to create, what could be the output, right? Could it be a bunch of different things? Like if you don't even know the difference between a matrix and a data frame, then how are you even going to decide what the output will be like, right? So a data frame is a very special data structure where you can have different columns. It's rows and columns. Trick question: whenever people say data set, 99.9% of the time, what do they have in mind? When people say data set,
Data frame.
sorry?
I think
Data
data
frame.
frame.
Yeah. So 99.9% of the time, if people say, oh, it refers to a data set, they are trying to communicate to you about the data frame. So you should know what they're trying to talk about. We're going to come back to data frame because it's very common. These are the two most common, of course they're all important, and each person has a way they work. I think of every solution I build in terms of a data frame or in terms of a list, right? For me, these are the two most important frames. Maybe I use a list more often than the data frame, but of course, it depends on the context and the problem you're trying to solve or the product you're trying to build. But yeah, you need to know all of this, but particularly, vectors, data frames, and lists. Then a list is an extremely important structure. And it's something you are all familiar with, right? When you're going to shopping, right? You make a list. Now, what is unique about the list? So let me ask you a pointed question. So it's not as if I'm asking you to read my mind. Is it possible for you to have a list of only one item? I mean, it's possible, but does that make sense a lot?
No.
No, like if you're just going to market to buy milk, like why in the world are you writing a list for? Like that doesn't make sense. So that you have a list. A list is made up of different items, right? So you have milk, butter, you have meat, rice, eggs, juice, bread, fruits, onion, and each of these things are very different items, but they all sit in one list, right? And that's why we have a list. That's why lists are very powerful, because we have different things. So here you have this is a what? Scalar. This is a vector. This is a matrix. This is a data frame. Now, in this case, I have these different data structures and I want them to be in one single data set. Well, what is the only option I have?
To put it in a list.
A list, exactly. Just think of a list. This is not complicated, right? This is just common sense. So the things you do every day, you have a list that is made up of very different things. It would be absurd if you say, okay, I'm going to put a different sheet of paper to write milk, and then I'll bring a different sheet of paper to write meat or rice, and then I have 5 different sheets of paper. That, like, why don't you just put everything in one sheet of paper? That is what a list is supposed to do. That is exactly what lists do. If you have different things and you want to put them together in one single data set, well, that's exactly why we created lists. So you put everything together, right? So when again, now you can start seeing just the huge implications of lists, because we use lists a lot. Because if you're building a product or feature, or even working with complex data, of course things are going to come in different forms. That is why lists are important. Now, trick question: a data frame is a list, true or false?
No, I thought at least it's inside there.
Sorry, is that sorry, Remy Uno, I don't know whether you're the one speaking. There's some background noise. Can you kindly mute yourself?
Yes, I think it's a list.
Absolutely, it's a kind of list. Of course, it's not like it's not like generalized like the true list, but it is a kind of list. So you have to keep that in mind, right? when we start writing some certain functions and we start referring to data frames as, oh, by the way, why is it a list? I didn't want to ask you why you said it's a list. Why do you argue that it's a list?
It's a list because it contains almost everything that a data may have. Variables, figures, characters, anything at all can be there. So I think it's a list.
Okay, I don't know. Okay. So here, in this column, we have numbers, right? And here we have string. And so, but they are all together in one single data frame. So yes, that's why it's a list. And you're absolutely correct. When you said figures, I thought you were referring to like charts or diagrams. I was like, okay. I wanted to say, okay, I'm not exactly sure about that, but it just occurred to me that you might be referring to figures as numbers or numeric, quantities. And so, so a data frame is a special kind of list. And so when we're talking about that, you have to put that in context, right? And this is what I'm saying here. This is a data frame. You can see here, this first column, we have date. What kind of variable is this? This type, that's the type of payment, whether it's card or cash. What kind of variable is this?
String.
Okay. It's a factor. It's a factor variable because it's categorical.
Scalar.
No, there's definitely not a scalar. This is a whole data frame. A scalar is just the number 5 by itself and not in touch with any other thing, right? So, but in this case, this is a data frame. All of this is a data frame or a data set, as people will call it. This is a factor variable. It's a categorical variable. This is, just maybe, string text. People can just type the location they were in. What kind of variable is this? The amount.
Numerical.
Numerical, exactly. And what's the difference between numerical and integer?
Integer is just a number without the points.
That's correct. So exactly. So
an integer. Okay, an integer is a whole number. It's a whole number without points.
Okay, that's correct. So a numeric variable is like the parent classification. So numeric is the parent classification that includes both integers and what?
Fractions.
And what do we call? Yeah, you're absolutely right. Fractions.
Variable.
Fractions. So what do we call fractions? What's another name for fractions?
I've forgotten the name.
Is it the floating?
Exactly. We call them floats.
Floating point number.
Look, yes.
All right. So numeric is a broad term that encompasses both integers as well as floats. All right. But that's not the point I was trying to make there. The point I was trying to make in this previous slide was that you can see that this data frame has different types of variables, right? Whether it's floats or whether it's numeric, whether it's integers or string or whatever. That is why we refer to data frames as special types of lists. And that is why we use this special function in R. This is one of very powerful functions in R called lapply. Lapply, who can guess what the L in lapply means?
List.
List, right? So lapply means that let us eat an elephant one bite at a time. So with lapply, it says, take this data frame and apply that function to every single column, one after the other, after the other, after the other. So that instead of me repeating the same operation 1, 2, 3, 4, 5, 6, 7, 8 times, I just write lapply and say, oh, hey, by the way, take each of those columns and apply that same function to it. Because the cardinal rule of programming is don't repeat yourself, DRY, don't repeat yourself. So if you find yourself having to do the same operation on each column, like you have already violated the cardinal rule of programming. And so that is why lapply comes in. And again, All this to say that we use lapply to a data frame because a data frame is a special kind of list. So when you're using lapply, don't be confused and saying, oh, but this is a list. It says list apply. So why are we using it on a data frame? Well, I've already explained to you that a list, and you've already seen why we can say that a list is a special kind of, a data frame is a special kind of list. Now let's talk about data frames, because that's the most common, especially if you're just analyzing data. Well, that's what you're going to be working with in general, most of the time. The structure of a data frame is rows and columns. We'll talk about the rows first, and then we'll talk about the columns. And this is, again, this should be very intuitive to you, because this is what happens in real life all the time. Well, if you're going to go down to find your seat, you first of all go down the row, which is the aisle, and then you find your seat, right? So the row always comes first. You have to go down the row, and then when you find your seat, you go down and put your luggage in the overhead container, and then you find your seat, which is the column, right? But you have to go down the row first. The same thing with shopping. If you're going grocery shopping, you have to go down the row, and then you reach up and grab whatever you want in the column when you get to that column. So it should be obvious to you that you have to go down the row first, and then you access the rows first, and then you access the columns next. All right. I even have to write a poem for you in case those of you who are poetically inclined. Rows are the heroes. They lead the way. So the heroes go first. All right. Then the columns come next. Now, this is a pop quiz. 2-5. What does this mean?
2 column 5.
Second column. Fifth row.
Somebody said second column.
Column.
Sorry, second row. Row
Okay.
come first.
Okay, second row and fifth column. Right. Do we all agree on that?
Yes.
All right, great.
Yeah.
What of this?
Fifth
Row 5,
Row 5
column 2.
column 2.
All right, awesome. We're getting the hang of this now. What is the if this is the data frame called mock DF? What's that cell in green? How would you describe it?
Row 1, column 5.
Fifth row,
No.
first column.
Row 5
Row 5,
No, row 5, column 1.
column
column
1.
1.
Exactly. So that's mock DF. Taking out the square brackets. We're going to explain what the square brackets are. That is row 5, column 1. And this?
Row 10,
Row 10 column 2.
Row 10,
Excellent.
column 2.
You guys are ready to write your functions now, your code. And this?
this
Column
is
1.
comma,
Okay, what
comma,
about the rows?
column 1.
It's,
Column
I
one.
think it's written from
Row
1
1
to
all the way
10,
down until row 10.
10 until,
So if we're selecting all the rows, do we need to specify?
yes.
No,
No, we don't have to specify it. So in this case, you can specify if you want, right? So you can say mock DF rows 1 to 10, comma, column 1. There's nothing wrong with that. It's just it just looks inelegant. All right, it looks kind of amateurish. Or you can just say row, mock DF, comma, we've completely omitted it. The comma is still here, right? To separate the rows and the column. It's just that where the rows were supposed to be, we've left nothing there. It's empty, which tells us that we're selecting everything. Is anyone confused by that?
No, sir.
Okay. Okay, another riddle for you. I am the most infectious thing in the world. What am I?
Smile.
No, that's wrong. There are some people that if you smile at them, they will still not smile. So that's why it's wrong.
Money.
Money? I wish that were true, that I could just hang around with some rich people and then get rich. I'm going to allow one more attempt.
Language also.
Huh?
Language.
Language. Okay, that's wrong. Okay, I'll tell you. NA. What is NA?
Not available.
Not available.
Or
And
Not
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 applicable.
applicable.
Not applicable.
or what? What do we call it?
blank.
What kind of value?
Null
No value.
and null value.
Missing.
Missing values.
It's invalid.
Missing value.
So NA is the most infectious thing in the world.
Yeah.
Why do we say that? So 1 plus NA,
NA.
1 times NA.
NA.
So
NA.
any arithmetic operation that involves NA will result.
Excuse me.
Yes.
What an A stands for? N stands for what? And A stands for what, please?
Missing value.
Missing.
Yes, missing value.
But that's not M, is N, please.
Sorry?
NA, not M. The missing M is missing is M, is it not?
You're right, M is missing, but we designate missing values in R as NA.
Oh, okay, okay.
Think of it as not available. Is anybody else confused by that?
No, sir.
No, sir.
All right. The person who has a question, are you clear?
Yeah, okay, thank you. I understand, sir. Thank you.
Okay, that's awesome. So anything that NA touches turns into what?
To NA.
NA.
Okay. Now we have a problem on our hands then, right? If we're taking the mean of this column here, there are 1, 2, 3, 4, 5. 5 rows. What's the mean of this?
1.
1.
What's the mean of this one?
NA.
Why?
Because NA
Because
is
NA are infected.
Because NA is there, right? And any operation that NA touches turns into what?
NA.
infected.
So what do we have to do then with this column? What if we want to take the mean of this, what do we have to do?
Remove
You have to
NA.
remove the
Excellent.
NA. Yes.
Excellent. So one of the functions you will see a lot in R is NA.rm equals true. When they're doing some operations, you're going to see that a million times. NA.rm equals true. NA means NA.rm. RM means remove. So we're saying remove NA. Yes, let's remove NA. So in coding, we just say NA.rm is true. Because if you say NA.rm is false, what do you think will happen to this? The mean of this will be what?
NA.
NA.
So just trying to provide you some context so that when you start seeing those things, it's not like Latin to you. It's like, okay, at least I understand what's going on. All right, so we've established that NA is the most infectious thing in the world. All right, so a verb. So we've talked about nouns. I hope everybody understands what nouns are, right? So nouns are objects, and we've talked about different objects: scalars, vectors, matrices, data frames, lists. Is there anybody who is confused?
No, sir.
All right, excellent. So now let's go to verbs. A verb is a doing word or an action word. Remember, if you went to primary school, that's what they taught you, right? So examples of verbs are drive, walk, read, swim. In all of them, there's action involved. That's what verbs are. Well, in R, we also have verbs like read, write, summary, head, tail, split. Those are also action words, right? And so, and most times you can guess what the action word is doing by just the word. So what do you think read is?
To read,
That
get
you
your
read data.
Exactly. You import data into R. And what of write?
Save
Excellent.
data.
You are exporting data from R, right?
Yes.
So you see, it's very intuitive. It's not rocket science. You import, you export, you read, you write. What do you think the verb call names does?
Get the column names.
Column
of your
names.
data.
Excellent. Get column names. What do you think the structure or STR? We don't write it in full, so please don't write the structure. It's just STR. I just wrote this part to show you what the full stuff was supposed to be, but we abbreviate as STR. Well, that gives you the data structure. So you can know whether it is a list or it's a data frame. You can tell whether it's a vector with that. It tells you the structure. What of dim or dimension?
If you use the
could tell
dimension
you-
of the data.
Dimension, I'll measure dimension in terms of rows, number of rows,
Rows,
Rows and
yeah.
and number of columns. So that's where it gets you. You tell it, okay, if for data frame, it's the number of rows, number of columns. The summary gets you the summary stats. The head gives you the top rows. And what do you think the tail gives you?
Bottom rows.
The
Exactly,
bottom
that's the
row.
bottom rows. So you see, it's not that complicated. Split allows you to split the data set into buckets. And we're going to talk about this tomorrow. Tomorrow we're going to write code tomorrow. Today is just getting you into the groove of knowing, okay, what does R even do? Bind, we have, C bind and we have R bind. What do you think the C and R represent?
Column and row.
Excellent.
Column.
So what do you think C bind does?
Combine the
It's the column.
column.
Exactly. So
Column
you
and
bind
rows.
together columns, stacks them side by side, right? And what do you think R bind does?
To bind two rows.
Combine rows.
So it stacks them on top of the other.
Like that.
Can you at least visualize it?
Sure.
Yeah, you need to visualize these things. Otherwise, it's not going to work. All right. Now, a very important part of programming is that you need to know the level of operation. Some operations have been done at the level of the entire data set, and some operations have been done at the level of a column.
Excuse me.
Yes.
Previous slide, I'm left line two areas. Please go back to previous slide.
Can you kindly repeat yourself again? Sorry, I didn't hear you.
May you go back to previous slide, please? There's something you speed it up. So I'm writing split, then split now data set into buckets. Okay, blind. Okay,
we're going to share the slides with you afterwards.
Okay. Thank you.
All right. So I was saying earlier that you have to know nobody can do this for you. You have to figure out whether a particular operation you're doing is at the level of the entire data frame or is at the level of a particular column. Certain operations are very column specific and certain operations are applied to the entire data frame. So let's compare that to a basket, right? A basket there are different fruits in the basket. So in this case, the basket with all the fruits represent what?
Data frame.
Set.
Yeah, exactly. It's our whole entire data set, right? In this case, the data frame. And individual fruits represent what?
Columns.
Sorry?
Columns.
The columns, exactly. So let's do this pop quiz and you will figure out whether a particular operation is the level of a basket or the level of a fruit. So we want to determine the weight of everything. Is that basket or fruit?
Basket.
Excellent. We want to snap a picture of a picnic basket for Instagram.
Basket.
We want to transport all the items to the picnic destination.
Basket.
Basket.
We want to know how a red apple tastes like.
Column.
We want to add a banana to your smoothie.
Column.
Column.
We want to count the total number of berries.
Column.
See, you guys already know this. We should end this session now. We should go home. Right. So yeah, that's just the fundamentals of it. So, so when you're doing your work, you have to figure out this operation I'm doing is the level, and at some point, you don't even have to think about this thing. It comes like you don't even have to think about it. It's obvious that, of course, this is an operation at the level of a data frame, or this is an operation at the level of a column. All right. What R has put apart, let no man put together. That's the rule of engagement for programming. So we've talked about nouns and we've talked about verbs. Those two have to be apart. We have to put them apart, right? And that is the function of the That is the function of the round bracket. So a verb is an action word. And what do you think the verb is taking an action on?
Age.
No, in general. Try to generalize things. A verb takes an action on a
noun.
Okay.
on a noun. Excellent. So a verb does an action to the noun. So we have our function that is working on an object, and we have to separate those two things. So when we say mean of age, which one is the action word?
Mean.
Mean.
Sorry?
Mean.
Mean is the action word. Which one is the noun or the object?
Age.
Age. And we must separate those two things by a round bracket. They must be apart. Do you see? So if you're used to writing code in Stata or other software where they don't have spaces, this is how you write the same function in Stata. You say mean space variable. But in R, whenever we're can you have a this is a pop quiz. Can you have a mean and not, can you have a verb without a noun?
Yes.
So what is the verb doing then? Like, can you have mean just existing on its own and not working on the noun?
Okay.
No.
No.
No. Wherever you have a mean, those two go together. They are like always in lockstep. So if you write your code and you're just seeing verbs and no nouns, then something is wrong. They have to be together. They are family. So you have to separate them with the bracket.
Together.
Now let's talk about punctuation. So we talk about nouns, we talk about verbs. So let's talk about punctuations and symbols. Who is confused at this point? Like, please don't be ashamed. Just let me know if you're confused. We can go back and clarify. It doesn't matter how trivial it might seem, but just ask your questions now. Any questions? Okay, I'll take that as a no. All right, so let's talk about punctuations and symbols. Like any other language, you need to learn the punctuations, and this is things like full stop, comma, and colon, semicolon. Those are. I mean, at some point in our lives, those were very hard for us to learn, but just use over and over made them solidified in our brain. So the same thing applies to any programming language. There are punctuations and symbols that we need to use. So let's talk about them. Comma. So the way we're going to do this is this. We're going to look at the English punctuation and we would parallel it with its relative or its sibling in R. So the comma links different things. So 1, 2, 3 tells us that they're all related. They're all part of the same thing. In R, the equivalents will be combined. So we're saying the C, it's like, think of it as, it's like, if you look at this bracket looks like somebody putting their arms around something, right? So I'm putting my arms around 1, 2, 3 and saying that they're all part of the family. So this is C putting his arms around this and saying, oh, these are all together. So so we use this operator when we want to indicate that a certain number of elements are all together. Does it make sense to use this combined element and only have one item inside? What do you think?
No, it doesn't.
Doesn't make any single sense. So, you need
Hello?
to have, yes, is there a question?
In the first part, we have seen that 1, 2, under. So under now is what? Is it the
No, we don't
stringent?
we don't
Is it a
put
string
the
or what?
and. We can just put 3 in R, that's fine.
Okay,
This do not translate literally. I'm just trying to create an analogy. So it's not as if they're like perfect, perfectly exchangeable. Does that make sense?
Yeah.
Yes.
All right, great. Apostrophe. Apostrophe indicates ownership. So when we say John's car, we mean the car that belongs to John. the equivalent to that is the $sign in R. So we remove the apostrophe there and we replace it with the $sign. So we say John $car. And that is telling us that the car that belongs to John. Any questions on that?
No, sir.
So if we go to this, so if we had this example here, right? So this would be basket, $sign, app one, saying that app one that belongs to the basket. If we go, okay, I can't go back. This is too many screens ago. Where we had the cars. Remember the picture where with many cars? Car one, $sign, wallet, the wallet that is inside car one, you know. So this just indicates ownership, that the item here. So it's just remember that you have to write it exactly like you do in English language. You don't say car John's, you say John's car. The owner comes first, and then the item comes next. So John's car. So same thing, exactly the same way you write it in English language. That's how you're going to write it in R as well. Any questions on that?
Yes, yes. Please, rule of engagement. Please, would you mind to explain further? It's not clear with me here.
Okay. The rules of engagement. We say that.
Let's go back first to it.
Huh?
Yeah. Where the statement is actually the rule of engagement. That there's a statement there. I don't know if no man can do what's something.
Let no man put together.
What R has put apart, let no man put together. We're just saying that don't put nouns and verbs together. Separate them with the round bracket.
Okay.
Does that make sense?
Yeah, right. I got it. And
I always put a lot of these very cheesy expressions. Just you can choose to ignore them, please. They're not that serious. They're just my way of being light-hearted. But anyway,
I have a question there. The C that you indicated and the combined is can you use any other alphabets apart from the C, or because you use the word combined, that's why you're using the first letter?
No, okay. It has to be C. It has to be C and it has to be lower C. That is fixed. You cannot change it.
Oh, okay. Wow.
That's a good question. So if you're putting this together, you're putting your arms around something, it must be lower C, and then you put whatever is there. It can be what is inside can be letters, it can be people's name like John, Jide, Toye, but of course if they're names, they have to be in quotes. Any questions on this so far? Are we all good? No? Why are you guys so quiet?
Yeah, good.
Very good, sir.
Is that
Okay, great.
We're good.
Hyphen. So when you say in English, we use the hyphen to indicate a range. So ages 18 to 60, right? So here we replace the hyphen with colon. So think of it as colon is saying from here, from the bottom to the top. That's one way you can think of it. So instead of saying 2, we just put a colon. So 18 colon 16 means 18 to 16. Does that make sense?
Please, I think 60, not 16. I mean, in the context of what has been written.
Oh, okay. So sorry, this is a typo.
Language.
Yeah, that's a typo. Sorry about that.
Yes, okay.
All right, let me correct that. Okay.
Hello.
Yes.
At the H on the right side, there's something H less than or greater. What is this sign? The sign there. Under the colon, where colon? Under the colon there, we have ages.
Okay, we'll talk about this in the next slide. Next slide.
Okay.
This is it here. It's saying, it's pointing and saying, go over there. Do you see that? So it's saying, go into that object. So it says, all of you 18 to 16, go into that object called what?
Less than.
Huh?
Age.
Called ages, right?
Ages.
Age.
The object is ages.
Exactly. So this is like, see, it looks like this guy pointing, right?
Yeah.
So I'm saying, yeah, this guy's. You remember that picture of Sarah with putting stuff in boxes to make it very clean, so that you know, oh, these are the legumes, these are the stuff. Yeah, this is how we put things into clean objects so that everything is very clean. We don't. I mean, it's kind of disorganized if we're just seeing 18 to 60, but if we just have ages, you know, when we want to extract the ages, we just know, okay, we just go to this container called ages, right? It's easier to work with it that way. Is that clear?
Yes, it's clear.
All right, awesome. Square brackets, very, very important bracket. We use it to indicate a subset. It's like, think of it, this looks like a square tray, right? At least it looks to me like, this looks like a square tray.
Yes.
What do you use a tray for? What is the only reason a tray is used for?
To spread things.
Okay.
To present something.
Okay, but the things are spreading or the things are presenting, that means that they came from somewhere, right? They came from a bigger source.
Yes.
So in this case, we have this big dish. I want to take out a smaller dish or just myself. So I used this tray to subset whatever I need from the bigger tray, right?
Yeah.
So when I'm writing, I'm going to say, this is the big pot and this is the tray for me, right? So if you go back to here, see, we said the whole data frame is called what? Mock deer.
Yes.
And we're just taking out this only part we want, which is what? Row 5, column
Row
1.
5.
So you can see how we're using square brackets here, right?
Yes.
We're subsetting. We're not referring to the whole data set. We just want to take out a small 7 for us to eat. So we use a tray to just pick out what we want. So the whole data frame is called mock DF, but we're not eating everything, right? We just want that small, tiny, little itty bitty piece. In this case, row 10, column 2. So we use a square bracket. So use a square bracket when you are just taking out a piece from a bigger whole. Does that make sense? You need to know these things because when we're writing code, you should be asking, oh, why are you using the square bracket? Why are you using the square bracket there? So these are the basic stuff you need to know. All right, let's go back to where we were. So, very, very important function. Finding a needle in a haystack. Find a needle in the haystack. This is a very, very important parameter or operator we use when you're trying to literally find a needle in a haystack. So, needle in haystack. So this tells me that the needle is in this large, haystack. So I say, for example, just grab the ages that are within, 15 to 100, right? This is age, needle in the haystack. The haystack is the bigger piece that I want to capture. The same thing, I say gender in haystack, So you use it to isolate a specific thing, in the context of what you're trying to capture. All right, let's look at Booleans. Boolean operators, or, and not. Or rhymes with more. So you can see or, more has or in it. So when you use plus, when you think of or, you should think of more and more and more. And think of and as band, because band has and. A band or a wedding ring means that these two people are now tied together. They have to go everywhere together, right? They're stuck with each other. Think of it as that's what the band does, right? So when you use the operator and, you are saying that these two guys are virtually tied together. They're stuck with each other. They have to go everywhere together. So if I say A and B, that means that if I find A only, I have to find B or else that stuff is false. And not means nothing. So again, keep that in mind. So if this is A and this is B, A or B means the union of A as well as B. So it means A as well as all of B. So all always results in something bigger. A and B means the area where there's A and where there's B, which is the intersection of A and B. It's just this tiny little piece there. Then A, not B, means A only, excluding B. So that's just all of A. So you have to know all of that. And the operators in R. So OR is a pipe. We call this a pipe symbol. This is not I, please. This is a pipe. You on your keyboard, this is shift and backward slash. That's what the pipe is, right? Think of it as, if you talk about the symbol, you can't remember what it is. Think of it as somebody on a straight road and the road bifurcates. I wonder, should I go?
Hello?
Yes.
What is the symbol of R? Or, I mean,
it's
is
a
it
pipe.
L or what?
Oh, it's a pipe now.
A pipe is on your keyboard, that's shift and backward slash. The icon beside your delete, to the left of delete.
Okay. Okay. All right.
You see, that's straight stuff.
Okay.
So that's what all. So just remember that this guy's on a straight road and the road bifurcation is like, should I go to the left or to the right? So think of it as a straight road that ends up bifurcating. Of course, and is very obvious. And then not is an exclamation mark, right? And so that's what that is. Some mathematical operators you need to know: equals, not equal, greater, less than, greater than or equal, less than or equal to. That should be pretty. That doesn't need any explanation. It should be pretty intuitive. All right, I have another riddle for you. I am the brainchild of a great Aristotle, the backbone of reason and the secret source of science and code. What am I?
Logic.
Oh, you guys are impressive. Or maybe you guys attended my last class. Either of those two. All right, great. There are two kinds of logic. We have deductive logic, and you can just remember them by the first letters. Deductive starts with D, so it's decreasing. Inductive starts with I, so it's increasing. So with deductive logic, we start from up top and then we decrease. So we start from a universal truth, and then we go down to a very specific use case. So say, for example, all humans have hearts. Of course, that's starting from the top, that's a universal truth. Alex is a human, so Alex must have a heart.
Go just to what? What's this thing? Okay? Leave the photos, okay?
Riri Johnson, can you please mute yourself? All right, so that's deductive logic. Inductive logic is the reverse. We start from a specific use case, and then we attempt to reconstruct a universal truth. So we say, Alex and the other two aliens I've met, so far all have just one eye. Therefore, all aliens must have a single eye, right? You need to understand logic. Especially if you're going to be a data scientist, like if you're going to, like, you cannot build software, you cannot write anything without logic. It's the backbone of programming, of software engineering, of everything you do. So logic is key. Now, in programming, what kind of logic do you think we use? Is it deductive logic or is it inductive?
I think it's inductive.
Sorry?
The first one, deductive logic.
Okay, yeah. Alrighty. I'll skip over some of this thing. So let's stick to the basics. But this is just giving an example of how we apply logic. Now I'll keep some of that part for tomorrow when we when we start writing our code, it's going to be more obvious about how that is. And so, AI versus automation versus rules-based programming. Again, this is inherently logic, right? By the way, what's the difference between AI and rules-based programming? What's the difference? Just regular automation versus AI. What's the difference as it relates to logic? You need to know those things because again, well, you may not be writing software, but you need to understand the fundamental difference in, I'm sure some of you are here data scientists, so because that underpins what we do, right?
So back to the deductive approach. Let me see. Please, can you go back? I'm having challenges with my network too. Very good. Is it the same word that they use for when you are doing your PhD? They say that go and learn about the inductive and deductive approach in physiological language. Is it the same word we are
all
applying
logic
here?
is the exact same thing you learn in philosophy, that you learn in programming, that you learn. Every logic is the same in the world.
Okay.
Unfortunately, our education is so poorly structured that it does not allow us to piece together all of it. So in our mind, they are very different things, but it is the same thing.
Okay. I've not gotten the concept now clear.
Okay, great. All right, back to the original question. What's the difference between AI and automation as it relates to logic?
In my opinion,
So
AI is okay, go ahead.
in terms of
AI,
logic,
AI,
you can
AI is
say
deductive.
AI is more
Automation is inductive.
deductive and automation inductive.
Okay. Any other thoughts?
I think automation is deductive and AI, wow. Yes, AI is inductive.
Okay. So when I write code, right? If I write code, I say, if this condition is met, then do A, B, C. Otherwise, do X, Y, Z. Who is making those decisions up front?
Writer of the code.
Sorry?
AI.
Writer of the code.
Exactly. The programmer, right? I wrote the code. I put a whole series of conditions. And this is why when you're writing your code, you have to make sure you cover every single possible condition that could ever exist. All right. That's why we always say, else, if all that things that we've not captured are there, then do this, right? So when I'm writing a piece of code to do some automation, I am the one determining the conditions under which the actions will be executed, right? So this is what if. This is a very powerful, in fact, this is the most powerful word in the world. If. It's a conditional statement that if this happens, then if this condition is met, then do this. Else, do the other one, right? I set the conditions. And you now come to the platform and you are clicking, but all the things you are seeing are based on rules that I've set, right? With AI, that is not the case. AI is the one making the evaluation in real time based on what it has learned. It's not some conditional logic that is saying it's not that somebody wrote some code that say, if this condition is met, do this. Otherwise, no. AI is the one making those rules in real time, right? So so we just need to understand how this connects back to this, right? In terms of logic and conditional statements and all of that. At least you need to have a fundamental understanding of what's going on and how that is different from rules. That's what we call it, rules-based programming. I set the rules as opposed to AI, where AI is doing the evaluation by itself and deciding based on what it's learned. All right, quick recap. Square brackets allows us to subset. This allows us to combine things. Pipe means or. Then another assignment indicator. We have our apostrophe, the $sign, which indicates ownership or possessiveness. Colon indicates range, and an exclamation mark means opposite. All right. Finally, documentation of code. Very important. I cannot obviously talk about programming without talking about documentation, because half of the headaches I have are related to documentation. So let's talk about documentation. It's very important to document code clearly. Explain the why, not the what. Of course, I can see that your code is doing particular action. Not tell me this code is doing this. I'm not blind. I can read the code. Explain the why, not the what, right? That is important. I'm not in your brain when you're writing the code. I need to understand what you were thinking. Like, why do you do it that way, right? That is what is important. You should have organized code structures, divide code into well-annotated sections or chapters. Sometimes I'm writing code that is so long that I have to break it into chapters, chapter 1, right, chapter 2, and then each chapter will have sections, right? It might sound like a lot of work, but it's very good for even for me. When I come back to that code, it's easy for me to know that, okay, wow, it reads like a book. Like, you tell a story with your code, so that it's just delightful reading your code, because your code is you're going to share your code with other people. If I write a piece of code, obviously I'm not the one who's going to implement the code. I have to give it to an engineer on my team, right? They have to understand the code that I wrote. Like, how else are they going to implement it, right? So you're not writing the code for yourself. You're writing the code for a team. So you have to make sure that the code is legible. Everybody can read the code clearly, and it's well annotated. Then you must use the variable names should be clear, should be intuitive. Please don't say Y2 or X1. Like, what does X1 mean? If your variable is saying smoking status, well, just the smoking underscore status, the name should be descriptive so that people can understand what you're saying. Use layman's terms. The goal is to instruct, not to impress. The point where we have problems is where people, and this applies to everything in life, whether you are talking to an audience, whether you are communicating on paper, you should never try to be impressing people. Just try to convey things. You know, it's just talking over people's head doesn't make you smarter. It doesn't. No, it doesn't. It's if you're going to spend time with you might as well convey knowledge. And so you should speak in the simplest way you can so that you communicate knowledge. And so the same thing applies to code. When you're writing code, the goal is not to impress people that, wow, I can write very complicated code. No, find the simplest way to solve a problem, you know. And then, most importantly, DRY, don't repeat yourself. Again, don't repeat yourself. What does that mean? Please, don't be copying and pasting code. If you have to copy a piece of code many times and be pasting, well, that means you have to write a function. That means that that's clearly an indication that you need to write a function and call that function instead of just copying code over and over and over. So again, DRY, don't repeat yourself. In R, we indicate functions. We indicate comment with the hash sign. So again, data analysis. Please, again, before you write a code, indicate the topic, your name, the date of that event, so that we know who wrote the code, right? So that we can come back and ask questions if there are issues. When you load libraries, tell us what each library, why it's needed, right? Don't write code without indicating the libraries that you use, because if I now try to run it, I will see errors because it will say, oh, this particular function could not be performed because we don't know the libraries that are needed. Again, remember, you're not writing it for yourself. Write the code as if you're going to die today, and somebody else has to pick up the work and continue from where you stopped. And so it makes it easy to understand, you know. And so, well, that's the end of our class. Any questions? We are right at the time.
Very interesting. Thank you.
Well, we're supposed to do data science, but you guys have converted it back to data analysis. So here we go. I'll say at the beginning of the course, the class, that when I wrote the course description, the goal was to talk about engineering, feature engineering, right? How do you apply data science in product engineering? The goal was never about analysis of data in the context of which we were speaking. But the feedback we got yesterday was people were like, oh, we thought we were going to talk about analysis of data and calculation of means. Well, that was not what I had in mind at all. It was supposed to be like more high level for people who are into product teams, like in engineering teams, and how do you think about product engineering and all of that. But we've come back to, we said we'll give the people what they want. So we're back to this. So tomorrow we would take a task and tomorrow we're going to write code and we'll see, okay, we'll take a task and say, okay, all these things we've talked about, how do you put them together to solve a problem, no matter how small the problem is. So that's our plan for tomorrow. Yes, I see some hands up.
Hello.
Please go ahead.
Yeah, would you mind to share with us where you can download the R and for us to install into our laptops?
Okay, you can do a Google search and I will find it, but we're going to share the links. I'm going to give you some homework, and that homework will contain the links for you to download it. But yeah, we'll have all of that. But you can, even before that, you can get with a quick Google search. But if you can't, never mind, we'll share with you the homework and how you can download. Now, I want everybody to try. Let's go back to the beginning, right? Aeschylus, the father of Greek tragedy, for those of you who were not in class at the time we started. He who learns must suffer. You cannot learn how to do anything without suffering. So there has to be some effort put into it. So the homework we're going to give today, you should try to figure it out by yourself. Please don't come to class tomorrow without having tried to figure it out. You can use ChatGPT, and it's not something, it's not anything complicated really. It's just, I'm going to just give you okay, let me see if I can describe the homework I'm going to give you, so you know exactly what I'm going to be asking for. So the homework will be something really simple. It will be something of this nature. You'll have names like John Doe. You have their email addresses, John Doe @gmail.com. You'll have their role, like, let's put the roles first. Let's make it simple. This is the Dean of Students. And then we might have, let's say, the office space, Turner Hall. So this is one person. And then Jane Doe, she's just at Turner Hall. And her email is janedoe@gmail.com. So some people might have, all the information, some may have just two, and you're going to have a whole bunch of them, right? And again, your job is simply to convert this into a format where you have name of person, you have their role, you have their email, their office space, and you have the email. So you're going to have a whole bunch of them, and it's just simple test of your ability to put everything together. Not complicated, something you can do in a few minutes. So in this case, this will be John Doe. So here we'll just say this is John Doe. The role is Dean of Students. The office is based in Turner Hall, and his email is this. For Jane Doe, there are some missing values, right? We don't have her role, so it will be NA, that she's also in Turner Hall, and this is her email here. So we want to convert this format. So this is NA here. So how do you do this, right? It's going to be a whole lot of them. So how do you do this? So essentially, that's a simple task that I have for you. So you have to figure it out. It's nothing complicated. So again, use ChatGPT, whatever you want, but I want to see the code. Before class tomorrow, please make sure you put your code in our LinkedIn page for me to review. So just write your code. You can take a just your code will suffice. Just dump your code in our LinkedIn profile. And Longile, please, if you can share our LinkedIn page so people know where to. And if you are, while you're at a LinkedIn page, you should definitely follow us if you haven't. So that when we have other announcements, you can follow. We had an 8-week course on data analysis a few months ago, and that was like very, very detailed. So when we have such sessions, you can definitely be the first to know. Is there any questions on the homework or any other thing?
Sorry, can you repeat the homework again?
I should repeat the homework.
No, just summarize.
Okay. You're going to be given a data structure, a data set like this that has a whole bunch of people's names. Some will have 4 rows, some will have 2 rows only in terms of information. Some may only have their names. All of them will have names. Their names will be there. John Doe, Jane Doe, Mary Joseph, Some may have just their names and their emails, right? Your job is to, let me make it simple for you, right? They will all have names, and some may be missing email. There will always be a space between one person's information and the next person's information. The number of spaces may be variable. You have 1 space for one guy, but 2 spaces for the other. But there will always be at least 1 space. What you have to do is to convert this structure, this data set from this form into this form. And please don't go and copy and start pasting manually. That's why I want to see your code. So that's what we're going to address tomorrow in our session. I want to see how all of these things come. Again, it's a very trivial task, but the idea is to see how you think about problems. It goes beyond just writing code. It's like, how do you think about problems? Because that's that's what we had the session yesterday. It's all about thinking about how am I addressing problems? How do I recognize patterns? And because pattern recognition is very important if you're going to be a developer or a data scientist. Any other questions? Yes.
Yes, sir. After this stage, when I prepare the list, I mean the Excel, what's next after this Excel?
Once you are done with this, that's all. That's all I need to know. That's all I need to see.
Only the table in the Excel.
Yes. Or you want more work?
I'm thinking if you are telling me that you prepare the coding like what's kind of some functions to be done in this Excel.
No. I'm not asking you to do it in Excel. I'm asking you to do it in R.
Oh, so what I'm confused here is, for example, I come up with this Excel. I made this kind of table. That's why I'm asking what's next after I'm preparing in Excel, this kind of things.
Okay, let me pull up some real data. Hold on a minute. Let me see if I can pull up some actual data to demonstrate what I'm asking of you. Hold on a minute. Let me messages. I'm looking for some random data that has all right. So let's say we're interested in this university contact, right? And we copied all of this information here. Longile, can you confirm you can see my screen?
Yes, I can see.
Yes.
Okay, all right,
yes,
great.
yes. Yes.
So I copy all of this information here. And let's paste it here. Okay, this is a pretty clean list. All right, all I need for you is to now write a code that would have this. So you see, this individual has their role, their number, and email. This one too has name, role, number, email. This one only has name, role, email. They're missing phone number. Exactly. This one has name and role. So this is okay. This is a perfect example. So this is a data set we're going to play with. So I'm going to share this with you. Your job is to create a final data frame that is simply this: name, role, phone number, email. So for this guy, this is his name, this is his role, this is his phone number, and this is his email. For this one, let me take this one. This one, this would be his name, this would be his, and this would be his email. So you're going to do all of this. So this is just the homework. Who is not clear about what the homework is asking for? Everybody's clear? Yes, please. Lloyd, please, you can attempt to explain it to them, please. Go ahead.
Good evening, Doctor. Hope you're good.
Yeah, we can hear you clearly, yes.
Okay, perfectly. So I think the confusion comes when people were speaking about converting it manually. So then imagine, let's say there was 50 emails and names. You can't do that manually for 50 people. It will take forever. And that's when we come with code to do that. So then the first thing I believe you have to do is now convert your Excel sheet into a data frame. And I believe you also explained it during the session. Once you now have your Excel sheet as a data frame, your plan now is to write code which will, number one, find out which names or which columns have missing data.
Excuse me?
And when, yes, can you hear me?
Interruption, please. What you said after Excel sheet, you can have data frame. What's next to that data frame now?
Or you convert your
all that part is for you to go and figure out by yourself. All I want is this. So you have this part here, and then you have this is what you are given. Again, remember our session yesterday. You have to figure it out by yourself. You are a data scientist who has just been hired, and the first task is, hey, just take this small data set, and please, can you just give me a data frame like this? Lloyd, please continue.
All right. So now you convert your Excel data sheet into a data frame, right? Remember, now you want to work with your data. Your data is, let's say in this case, it's the information of Australian University. So then you can work with this directly in your R. You first need to convert it into a data frame, and a data frame can then be manipulated. So then you now first need to find out, okay, well, before you even find out what's missing, so you mentioned that you need to have it in columns, right? So now you need to write code, and this is up to you. Do your research, write code where you can now convert it from one. You see there you have one column. Now convert it into multiple columns, which has name and I think email number and all that. And once you have converted it into columns, then check which column has missing data. And then I believe you can do the rest for yourself.
So there are many ways to skin a cat. You can figure out however you want to do it, right? Like there are many ways to skin a cat. So how Lloyd explained is one way, but what I want you to do, what I need you guys to do is to go and figure it out. You have to go and figure it out. So I'm not going to explain to you how you want, no, like again, remember yesterday I talked about the attributes that are bad in a data scientist. One is somebody who needs to be babysat that I give you a task and then you are now asking me, how should you do the task? My job is to give you the task and your job is to figure it out. That's how it works. So that is the mindset that I want you to have. Again, Aeschylus, right? You have to try and figure it out. So please, that's what the requirement is like. Is there any other question? Who is thoroughly confused about what the ask is?
Okay. Good evening, everyone. Thank you for the teachings. Mine is not a question. Mine is just that I don't know how I can get these lessons from yesterday. I wasn't available yesterday and I came in late today.
Okay.
So I don't know.
Lungile would comment on that and make sure everybody gets access.
All right. Thank you.
So, but any questions on the assignment or the homework? Quada, you have your hand up.
Yes. Good evening and good afternoon. My question is that after we might have finished our tasks, how can we share it on the LinkedIn, on the Chisquares LinkedIn? How can we share it?
You go to our LinkedIn page and you go and you just submit your comment there. You dump in your so you go to our LinkedIn page and you can, let me see if I can figure out our page. How do I go to this page now? Chisquares. All right, I think this is it. And Lungile, you're going to make a post, right? And then they can submit their homework on that post. Is that how you want it done?
They can just respond, send them as responses to our data science flyer.
So let me see if I can find the flyer. Let's see.
It's the first. It's pinned on top.
First screen on top. Let's see. Sorry, I'm not very familiar with this page.
View as a member.
View as a member. Okay.
But they will find it. Posts.
Okay.
Posts.
Posts. Okay, this one, right? So please, find this page and come and post comments under it and say,
comment.
Here is my code. Then you paste your code there. Is that clear?
That's all.
Okay, great.
Okay, sir. Thank you.
And again, the whole point of this session is for you to figure it out. See, this is what I was saying yesterday. This is why that session yesterday was so important. There is no way you can call yourself a data scientist if you cannot figure things out. So, so this is just a small example of this is where we start, right? But you should be able to sit down and say, okay, how do I even solve this problem? How do I take a big problem and break it into small parts and solve it? And please don't go and be copying and pasting Excel, whatever you do. GROI, don't repeat yourself. It's supposed to be, this is just a very simple homework that you should be able to write just a few lines of code and solve the problem. Any other questions? Yes, Usman, you have your hand up.
Doctor, good evening, sir.
Yes, good evening.
Good evening, sir.
Yes, I can hear you.
My question is, what is the relationship between the data science and the Chisquares?
Chisquares is we're a tech company. So of course we have a lot of data scientists. We build tech products. So of course you need data science. You need data science, but you also need a whole lot of other experts. I don't know, were you in our session yesterday?
I was there, sir.
Okay, well, the bottom line is that yes, Chisquares is we're a tech firm. So while we teach and share knowledge, that's not the key thing we do. We build scientific technical products. And so we're a company that writes code morning till night. And so we have a whole lot of data scientists amongst other professionals. Does that make sense? So when you go to the Chisquares platform and you click on something and something happens, of course, there's a lot of code going under. It's code that makes it happen, right? When you go and you click download or you click anything and you see results, that is what is code that makes it come alive, right? And that code is written by, amongst other people, data scientists and back-end engineers, front-end engineers, and a whole lot of other people. I hope that's clear. Okay, I will assume it is. Any other questions?
So thank you, Doc. I wanted to say that in as much as we have swayed you away from the product engineering stuff you wanted to share, I was pleading if you have a session on that later, after we are done with the pool taking you away from the main thing. Thank you.
Oh, sure. I mean, we can have a feature session, but the thing is that every time I announce that we want to have a data science session, all these people will come and say, oh, and then they will compare, oh, we thought it was going to be. So it's always going to be a vicious cycle. And so, but yeah, I think we can have a session among people who just want to build products. And maybe there are some of you in the audience who just who want to start a tech company or just things of that nature, and you're interested more in the weeds. You want to go into the details of and so definitely that's something we could have a special session for. And it doesn't have to be a whole lot of people. It could be just 10 people who are really interested in that and who have some, but of course that requires some base level of knowledge. You can't necessarily come to that kind of session and say, I have never heard about Python. Or I was like, okay, so why are you here? So that may not work, so yeah, so I think, and also I think we just have to put it in the flyer much more clearly that if you are not in this direction, please just keep right. Just, this is not for you. So yeah, we can definitely have that kind of session some other time too. Any other questions? So let me share the files with Lungile so she can any other questions? Are we all set?
Did you show them how to install the R Studio? I didn't join yesterday. The R Studio, how to do it, the interface, how to explore interface.
Okay. Please do not post the homework. Do not post the Excel spreadsheet because it contains actual people's names. So of course, even though we got it from the internet, that doesn't still mean we want to just post it. So all I just want to see is the code behind what you did. So we're going to share part of what Lungile will share, and Lungile will tell us how she wants to do it. Will be the spreadsheets, but also the notes from the classes, but also the homework. All right. Any other questions? Are we all set?
Did you hear me? Please, did you hear me, Mr. Israel?
Could you ask your question again then?
I'm saying how to install the R Studio and other things. I don't know if they were taught yesterday.
Yeah, I said I answered your question. Actually, I said the instructions for the homework will be in another document, and that will contain everything you need to know.
Okay. So between R and Stata, the last time you taught us, what is the difference? The R functionality and then the Stata. You took out Stata and then the R. and that of Python. What is the difference? Is it that if it's good to know R, still know Python?
They're different
Data,
languages.
Okay. Because Python also depends on code.
Sorry?
I said Python, you also need to code. With Python, you also need to write codes.
They're all programming languages here. Yeah, so you will need to write code. Okay, I believe we have answered all the questions. Is there any other one last opportunity for the last question? Okay. I guess not. All right, thanks so much, everyone. I will see you in class tomorrow.
What time?
Bye.
Thank you so much.
Oh, you're welcome. Yeah. All right, take care.
Thank you, Doc. We are very grateful for this session.
Thank you, Doc. Good night.
Thank you, Doctor. Good night.
Good night, Doc.